Decode Ways. You have intercepted a secret message decoded as a string of numbers. The message is decoded via the following map, and this is the map from A corresponding to all the way to Z with 26. However, while decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes. For example, 2 and 5 and 25. For example, 11106 can be decoded into this or this. KJF could be put as this. So what this is basically saying is that 25 and 25 could be decoded in different ways. Could have different meanings to them. So there may be things that are impossible to decode, given a string as containing and only digits return the number of ways to decode it. If the entire message cannot be decoded in any valid way, return 0. So let's keep note of this. Oops. So this is our S. For example, here S is 12, and we have 2 ways to be able to decode it because 1 or 2. Wait, hold on. This could be decoded as A, B, or L. So 1, 2, or L. Okay. So in this example, we have 3 values. S is 2 to 6, and we have output 3 because it's 2 to 6 could be decoded as BZ, VF, which is this, or BBF. And here 0, 6, we have 0 because 0 cannot be mapped to DF because of the following. Okay. So let's get into this. How will we do this? Let's make our edge case for this 0. So if S, if not S, or S, no, hold on. S, first index is equals to 0. Return 0. Let me take the O, make it a 0. So now let's make our len of S, and then let's make our DP table array. DP array to store values of numbers of numbers of ways of decoding S. So let's call it DP equals to let's make our list, and then what should we put? Let's put zeros in there. 0 times n plus 1. Let's put this in parentheses. So now let's make our base cases. So dp of 0 is equals to 1. dp of 1 is also equals to 1. There's only one way to decode an empty string. Also, there's only one way to decode this is the end. One character. So now let's iterate. So for I in the range of, so once we are able to get past these base cases, let's go from 2 to the n plus 1, or because or we can just put a len of dp, since we want to get all the indexes from this. So let's check. Let's check for single digits. Single digit is equals to int of s I minus 1. So we start from 2 minus 1. 1. So the first character in for example here, these two, it will come here, and then it would take 2 of it would check, it would come through here, and then 2 minus 1, and this will be the value here, and that's basically it. So now, so let's check if a single character cannot be a 0. So if single digit is equals to, not equals to 0, let's make our dp, the current I that we're on, equals to dp I minus 1. So this would basically be oops, forgot a plus here. So this would basically take the previous number that we had before this value here. So so before 2 here, oops, I forgot the 2. So from 2 on, so before this 2 over here, we were at 1. So it would be 2 minus 1, and then take that value, which is 1, and then add it to this. and so that's our D2I currently now. So now let's check for double digits. So double, I'll call not double digits, not two double digits, I'll call double digits. Digits equals to int s t on s, this time it's hold on, int I minus 2, and then hold on 2. So from I minus 2, and then I from, so for example here it would be 2 minus 2, which should be 0, and then all the way to 2. So from 0 to 2. If double, nope, if double digits is greater than 10 or equals to 10, double digits is greater than 10. Double digits, take that equal and also no less than or equals to 26. Less than or equals to 26. Let's take di, hold on, di plus 1 dp, nope, dp I minus 2, and then take yes, 2, it should be 2 this time. So that's basically it. Let's move out of this and to a return dp and the current and the length of it. That's going to be the total amount. So let's see. It says syntax error. Oops, there. I keep putting this there every time I not single digit. Oops, another syntax error. Let's see if there's any more. di dp, another one. Boom, and finally we've been able to pass the 3 cases that we're given. So in this case, the time and space complexities are both time and space complexities are both of n. Time to run it goes linearly with the size of s, and space to store it in dp goes linearly with size of s. And that's it for this problem. Let's submit it to see if it's going to pass all cases. And it's been able to pass all cases.